Here I want to talk briefly about hormones that signal through receptors located inside the target cell, the intracellular receptors. There are one category of hormones and one specific hormone that signal in this way. So we'll be talking about the steroids, it's a broad category of hormone, including the corticosteroids from the adrenal cortex, and we'll be talking about thyroid hormone. There are some slight differences in signaling between these two categories of hormones, between the steroids and the thyroid hormone. So we're going to deal with each of them individually. We'll talk about the steroids first. So in order to visualize how signaling happens when we're talking about a steroid hormone, we need to draw the plasma membrane. This is the plasma membrane of the target cell. But we also need to draw the nuclear membrane. Now, steroids are a category of lipids, which means that they are lipid soluble and they can cross the plasma membrane directly. So we'll draw our steroid hormone, and this can cross straight through the plasma membrane. They still need to interact with the receptor, though. Just the steroid hormone alone isn't going to do anything. But the receptor is just hanging out inside the cytoplasm of the target cell, waiting for that hormone to show up. So once that hormone comes in, you end up with this little hormone receptor complex. The hormone binds to the receptor, and they stick together. This hormone receptor complex can pass through pores in the nuclear membrane, going straight into the nucleus. Now, we all know that in the nucleus you have your cell's DNA. This hormone receptor complex actually binds to the DNA. So the receptor sits on the DNA. The receptor can't enter the nucleus until it's bound to a hormone. And once that hormone receptor complex gets in, it binds to the DNA. You can get changes in which genes are transcribed from that DNA, and that change in transcription leads to a change in cell activity. And that's how steroids cause a change in cell activity. Okay, now let's talk about thyroid hormone. Here we have our plasma membrane. Here we have our nucleus. And to understand what thyroid hormone does, we also need to add one more player. And this is our mitochondria. I'll abbreviate it MT. Now, thyroid hormone actually is not a lipid-soluble hormone, but there are special channels that actually bring thyroid hormone into the target cell. So thyroid hormone does, in fact, cross the plasma membrane, but it has to pass through these little channels. But once that hormone gets inside, once that thyroid hormone gets inside, it acts on receptors in a couple of different locations. You actually have receptors that are located in mitochondria and receptors that are located in the nucleus. The receptors in the nucleus actually sit on the DNA. The thyroid hormone receptors sit on the DNA, but they can't do anything. They can't allow transcription to start until thyroid hormone comes in. So once thyroid hormone enters the cell, thyroid hormone interacts with its receptor on the mitochondria and changes the functioning of the mitochondria. Remember that a lot of thyroid hormone's activities are dealing with cell metabolism, and increase in thyroid hormone increases cellular metabolic rates. And so it makes sense that there would be changes in how the mitochondria respond when thyroid hormone is around. So thyroid hormone acts there. Thyroid hormone also enters the nucleus and binds to that receptor that's just sitting there on the DNA. And once thyroid hormone is bound to the receptor, you can get transcription happening. So you get gene activation, and that leads to a change in cell activity. So somewhat similar to signaling by steroid hormones, both acting on intracellular receptors, but a few subtle little differences. Thyroid hormone has the mitochondrial receptors, and it binds to a receptor that's already in the nucleus on the DNA, just waiting to get activated by thyroid hormone. And that's it for our discussion of the intracellular receptors for hormones.